So now in this video, so we shall be discussing about causality for LTI systems. Causality for LTI systems. Causality for LTI systems. So what is a causal system? A system is causal if its present output depends on the present input and the past inputs, but not on the future inputs. Okay, so that means a system is said to be causal if it depends only on the past and present inputs, but not on the future inputs. If the system depends on the future inputs, then that is said to be a non-causal system. Okay, anyhow, so let me go with the y of n once again. So y of n is can be written the output of the LTI system. Y of n can be written as h of n convolved with x of n. So this thing we already know that, so we can interchange this as well. So that is equals to summation n, not n, so that is summation k is equals to minus infinite to infinity h of k x of n minus k. So this is the convolution sum, we already know this, and let me split this summation. So summation k is equals to minus infinity to minus 1 h of k x of n minus k, and this is one summation, that is another summation k is equals to 0 to infinity h of k x of n minus k. Okay, so that is equals to, let me expand this. So I can expand this when we take k is equals to minus 2, that is h of minus 2 x of n plus 2 plus h of minus 1 x of n plus 1, and this is associated with this one, plus, and this can be written as h of 0 x of n plus h of 1 x of n minus 1 plus h of 2 x of n minus 2, and it goes on. Okay, if you carefully observe in this equation, and x of n plus 2 and x of n plus 1, okay, which are the future inputs, are associated with the impulse response h of minus 2 and h of minus 1. Okay, h of minus 2 and minus 1, and when it comes to the x of n and x of n minus 1, x of n minus 2, so this is the present input, and these two are the past inputs, and the next coming terms are also related to the past terms, and if you carefully observe them, these are all the past and the present inputs, and these are all associated with the h of 0, h of 1, h of 2 and h of 3, like that. Okay, from this we can observe one thing: if the impulse response has positive values including 0, if the impulse response has positive values including 0, then the system is depending on the present and as well as the past inputs. Okay, that means if the impulse response is having the negative values like this, that means which are associated with the future inputs, then we can say the system is depending on the future inputs. From this we can derive an equation. So in terms of impulse response, okay, we can write that as h of k is equals to 0 for k less than 0. So that means h of k must be 0 for k less than 0. That means it should exist only for positive values of k, but not on the negative values of k. Okay, now, so that means I can rewrite the equation. So in terms of impulse response, let me write that means h of n is equals to 0 for n less than 0. Okay, if any system impulse response is satisfying the equation, this equation, then we can say that the system is causal. Okay. So, this is another condition, h of n is equals to 0 for n less than 0 is a causal system. Okay. And the same condition, so we can rewrite the equation now. So, the output y of n is equals to summation k is equals to, so k can be only the positive values from k is equals to 0 to infinity h of k x of n minus k. We can rewrite the equation as k is equals to 0 to infinity h of k x of n minus k. Similarly, we can extend this topic to the continuous time LTI systems, that means causality. So, we can write this as h of t is equals to 0 for t less than 0, and the output y of t is equals to, so normally, so integral 0 to infinity h of tau x of t minus tau d tau. So, previously, so earlier, so we would be writing this as minus infinite to plus infinite h of tau x of t minus tau. Now, because the impulse response should be positive, that means the impulse response should be like this. This is the time. The impulse response should exist only for positive values of time. It should not exist for negative values of time. This is the impulse response. The impulse response can be anything. So, let us consider this is my impulse response, and this impulse response exists only for positive values of time and negative values of time. If the impulse response is like this, we can say that the system is causal. System is causal. Otherwise, the system is non-causal. Okay. Earlier, we have seen systems with and without memory, and we have related all this system properties with the impulse response. By looking into the impulse response, we will be able to tell whether the system is memory system or a memoryless system, or we can say that system is a causal or non-causal system. Thank you.